Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This is a great site for preparation for your class 12 mathematics, physics, chemistry examinations as well as your entrance examinations. You must download our app. The link is available in the description box. Students, today we'll be solving CBSE class 12 Delhi 2020 set 3 paper. We already have discussed set 1 and set 2 papers in separate videos. So you can refer to those videos as well. This set 3 will have only those questions which are not in set 1 and set 2 papers, right? So let's start with today's video for this set 3 Delhi 2020. Here's question number 1. Best of luck. Let's start. If A is a skew symmetric matrix of order 3, then what is the value of A's determinant? Since A is a skew symmetric matrix, it is skew symmetric. It's given to you. That means A transpose is equal to minus A. And determinant of A transpose will also be equal to determinant of minus A. And you know one thing, minus A, this from here, minus A is equal to minus 1 raised to power n into determinant of A. Where you know n is the order of the matrix. Right? So here n in this question, this is equal to 3. That means minus of A, determinant of minus of A is equal to minus 1 raised to power 3 determinant of A. This gives you determinant of minus A is equal to minus of determinant A. Now, substituting this in this equation, let's say this 1. So substituting this equation in 1, you get A transpose is equal to minus of A's determinant or minus of A determinant. Let's write here. This is equal to the determinant of A transpose. Now we know for any matrix, determinant of A is equal to determinant of A transpose for any matrix. So replacing this in this equation, you have, let's say this is equation 2. So now substituting this in equation 2. This in equation 2, you have a determinant of A is equal to, determinant of A is equal to minus of determinant A, right? That means 2 of determinant A is equal to 0. It simply gives you determinant of A is equal to 0. That's it. This is what you needed to find out in the question. And the answer to this question is equal to 0. That's it. Hope you understood. Next is question number 2. If y is equal to log to the base e x squared upon e squared, then what is the value of the second derivative of y with respect to x? We are given y is equal to log e x squared upon e squared. Let's find the first derivative, differentiating both sides with x. You have this 1 upon x squared upon e squared into the derivative of x squared upon e squared. This is equal to e squared upon x squared into this is 1 upon e squared into 2x. This x and x will cancel, e squared will cancel, and you will have this is 2 upon x. This is dy upon dx. Now let's again differentiate both sides with respect to x. We have d squared y upon dx squared is equal to d of 2 upon x, which is equal to minus 2 upon x squared. This is the answer to the question. Hope you understood that. Let's move to the next question. Question number 3, the distance of the origin 0, 0, 0 from the plane minus 2x plus 6y minus 3z is equal to minus 7 is how many units? So, see, this is the plane. Equation is minus 2x plus 6y minus 3z is equal to minus 7, and Origin, distance between these two, this plane and the origin is given by, say, first of all, let's write down the general equation for that. General distance is given by, this will be 2, okay, let's say A into x1, B into y1, C into z1, whole divided by the root of A square plus B square plus C square. Okay, so here in this question, this is A, this is B, this is C, this is X, Y, Z. So this becomes distance is equal to 2 into 0 plus 6 into 0 minus 3 into 0 whole divided by root of 2 square, 6 square minus 3 square, which is equal to 0 upon something like 4 plus 36 and 9. This is root of 49, right? So that means the distance from the origin to this is 0. To this point is 0. Sorry, plane is 0. Distance of plane, given plane to the origin is equal to 0. Question number 3, the distance of the origin from this given plane is equal to dash. Fine. So we are given the plane as minus 2x plus 6y minus 3. First of all, let's write down the general equation. If you are given ax plus by plus bz plus d is equal to 0, this is the required equation of this is the equation of the plane, and there is a point x1, y1, z1, and you have to find out the distance between the two. Then the distance is given by the formula a into x1, b into y1, c into z1 plus d whole divided by root of a square b square plus c square. Right. So here a is in this question, it is minus 2x plus 6y minus 3z plus 7 is equal to 0, and the given point is 0, 0, and 0. So according to the distance formula, it is given by, it was the, wait, minus 2 into 0, yes. 6 into 0, minus 3 into 0, whole divided by root of minus 2 square, 6 square, and see here I forgot to write plus 7, okay, and here is minus 3 square, okay. So this becomes, this will be equal to 7 upon root of 4, 36, and 9, which is equal to 7 upon root of 49 under the mod, that is equal to 1. Because root of 49 is equal to 1, so this is equal to 1. We have taken the mod. Of course, the distance is positive always. That means you have option A as your correct answer. Hope you got that. Let's move to the next question. Question number 4 is A and B are square matrices, each of order 3, and determinant of A is equal to 5, determinant of B is equal to 3. You have to find out the value of determinant of 3AB. You have to find out this. First of all, you are given determinant of A is equal to 5, B determinant is 3. You have to find out determinant of 3AB. Now, this is equal to 3 raised to power, since it's a 3 order matrix, so 3 raised to power 3 into determinant of A into determinant of B, right? Because determinant of A into B is equal to determinant of A into determinant of B. This is equal to 27 into 5 into 3, 27 into 15, which is equal to 405. So the answer to this question is 405. Hope you understood that. Next, question number 5. You have to find the cofactors of all the elements of this matrix. Fine. So this is actually very easy. The cofactors, let's write down the first cofactor, that is C11. So I'm leaving first row, first column. It is equal to 3. C 1, 2, first row, second column. Wait. So this is equal to 3. Now, first row, second column, first row, second column, this will be equal to 4. Since there is minus 1 raised to power 1 plus 2 into 4. Here was the same thing, minus 1 raised to power 1 plus 1 into 3. This is equal to 3. And this is equal to minus 4. second row, first column. So now I'm having second row, first column. This is equal to minus 2. So minus 1 raised to power 2 plus 1 into minus 2. This is equal to 2. Second row, second column is minus 1 raised to power 2 plus 2. So second row, second column, this is equal to 1. So that's equal to 1. So we found all the cofactors. This is only we needed in the question. These are the four cofactors and answer to our question. Hope you got that. Next is question number 6. If fx is equal to, here is the x into modulus of x for all x belonging to real numbers, check its differentiability at x is equal to 0. See, you are given this fx is equal to x into mod of x. So here fx is equal to plus x into x for x greater than equal to 0. And this is equal to minus x into x for x is less than 0. Here fx is equal to, of course, x squared. This is minus x squared when x is greater than 0 and when x is less than 0. Now we have to check for the differentiability at x is equal to 0. For that, let's find out the right hand derivative first. RHD will be given by limit h approaching 0, f of 0 plus h minus f of 0 whole divided by h. That's equal to limit h approaching 0, 0 plus, this is equal to, 0 plus h whole square minus 0 square upon h. This will be equal to limit h approaching 0, h square upon h. And this is 0. So this is equal to nothing but 0. This will cancel and this answer, the right hand derivative will be equal to 0. Let's go with the left hand derivative. So for the left hand derivative, limit h approaching 0, f of 0 minus h minus f of 0 whole divided by minus h. This is equal to limit h approaching 0 minus of 0 minus h whole square minus 0 square divided by minus of h. This will be equal to minus h squared upon minus h under the 0. Like, it doesn't matter. This minus and minus will cancel h and h will cancel. Limit h approaching 0. H is equal to 0. Here, that means I got the left hand derivative equal to right hand derivative, which means fx is differentiable at x is equal to 0. Right? So we had to do the same thing in the question. We had to check for the differentiability at x is equal to 0. Yes, it is differentiable. Hope you understood that. Let's move to the next question. Question number 7, you have to find the integral of x plus 1 divided by x plus 2 into x plus 3 dx. Let's say this is equal to y. I'll solve x plus 1 upon x plus 2 into x plus 3 separately by using the partial fractions. This can be written as a upon x plus 2 plus b upon x plus 3. So taking the LCM and cancelling the denominators, you will get x plus 1 is equal to a into x plus 3, b into x plus 2, or x plus 1 is equal to a plus b into x. I'm segregating the x and the constants terms. This is equal to 3a plus 2b. Comparing the coefficient of the respective terms, that is the coefficient of x in this case is a plus b, and on the left hand side the coefficient of x is equal to 1. So this is equal to 1. Similarly, the constants 3a plus 2b is equal to 1. Here you have b is equal to 1 minus a. So this can be written as 3a plus 2. b is 2 into 1 minus a. This is equal to 1. So that's 3a plus 2 minus 2a is equal to 1, or a is equal to minus 1. When a is equal to minus 1, b will be equal to 2. So you got the value of a as minus 1, b as 2. Therefore, x plus 1 upon x plus 2 into x plus 3 can be written as minus 1 upon x plus 2 plus 2 upon x plus 3. Let's find the integral on both the sides. This is what we have to do in the question, right? So this can be written as minus 1 integral of 1 upon x plus 2 dx plus 2 into 1 upon x plus 3 dx. That's equal to minus log of x plus 2 log of x plus 3 plus c. So this can be written as log of x plus 3 square divided by x plus 2 plus c. This is the answer to the question. Hope you understood that. So let's move to the next question, number 8. You have to find the value of integral 0 to 1 tangent inverse 1 minus 2x upon 1 plus x minus x square dx. Okay. So I can write it like this is equal to, let's say this is equal to I. So this I is equal to limit 0 to 1 tangent inverse 1 minus x divided by 1 plus x into 1 minus x dx, right? That's equal to integral 0 to 1 tangent inverse. See, if I take this as a and this as b, so this is the formula for, like this is something tangent inverse a minus b upon 1 plus a into b. So this is the formula for tangent of 1 minus x minus tangent inverse of x dx, right? This is the formula of tangent inverse a minus tangent inverse b. So this is equal to limit 0 to 1 tangent inverse 1 minus x dx minus tangent inverse x dx. Now I'll be using the limit 0 to 1. I have the one formula both, that is limits 0 to a. I'm using this. F of x dx can be written as 0 to a f of a minus x dx. So using this, now it can be written as limit 0 to 1 tangent inverse 1 minus x dx minus tangent inverse of x. I will not touch this. I will leave it as such. So this is equal to limit 0 to 1 tangent inverse of x dx minus limit 0 to 1 tangent inverse of x dx, which gives you 0 because they will cancel out. So that means this whole integral value is equal to 0. That's it. This is the answer to the question. Hope you understood that. Let's move to the next question, number 9. So here you have the question number 27 to 32. They are from the section C. They each carry 4 marks. Like 27 to 32, we are about having 5 questions. So they will have the 4 marks, right? Of course, in this set, we will not have all these questions because some of them have already been discussed in the set 1 and set 2. So let's start with that. You have to find out the value for x. You are given this equation. Let's write down the equation. You are given sine inverse 5 upon x plus sine inverse 12 upon x is equal to pi by 2. So I will take it like sine inverse 12 by x is equal to pi by 2 minus sine inverse 5 by x. I will take this sign on the right hand side. So you will have 12 upon x is equal to sine of pi by 2 minus sine inverse of 5 by x. So sine pi by 2 minus something, it will be changed into cos of sine inverse 5 pi by x. Now you have one more identity over here, that is cos of sine inverse x is equal to root of 1 minus x squared. So that means this is equal to root, this 12 upon x is equal to root of 1 minus 5 upon x whole square, or squaring both sides, you have 12 upon x whole square is equal to 1 minus 25 upon x square, or 144 upon x square minus 20 plus 25 upon x square is equal to 1. This gives you 169 upon x square is equal to 1, or x square is equal to 169, which gives you x as plus minus 13. So we have to find out two values. See, I'll try for both the values to check whether they satisfy the given equation or not. Your given equation was sine inverse 5 by x plus sine inverse 12 by x should be equal to pi by 2. Now let's check for x is equal to positive 13. This will be equal to sine 5 upon 13 plus sine inverse of 12 upon 13. This should be equal to pi by 2. Sine inverse A plus sine inverse B has a formula as sine inverse A root of 1 minus B squared plus B root of 1 minus A squared. So this can be written as a sine inverse. This is A and this is B. So 5 upon 13 root of 1 minus 144 upon 169 plus 12 upon 13 root of 1 upon 25 upon 169. So this gives you sine inverse 5 upon 13 into this will be 25 upon 169 plus 12 upon 13 multiplied by root of 144 upon 169. So this is equal to 25 upon 169 and 144 upon 169, which is sine inverse of 169 upon 169 or sine inverse 1. You know, sine inverse 1 is equal to pi by 2. So this equation is satisfying the given equation. X is equal to 13 is satisfying the given equation. That means this is one of the answers. Now let's check for x is equal to minus 13. See, when you will check for x is equal to minus 13, it will not come out to be pi by 2, right? This is actually a bit lengthy process. Anyways, let's go for that also. So you had the sine inverse minus, now it will be minus 5 upon 13 plus sine inverse minus 12 upon 13. This should be equal to pi by 2, right? So see, all of these terms will come out to be negative. So negative, negative. This means here the answer will be equal to. So this will be negative and a negative number. So the answer over here will be minus pi by 2, which is not equal to pi by 2. Hence, x is not equal to minus 13, which is satisfying this equation. But yes, x is equal to 13. This is satisfying the equation. So that's the answer to our question. Right? Hope you got that. Next is question number 10. So in this question number 10, you have to find the general solution of the differential equation y into e raised to power x upon y dx is equal to x into e raised to power x upon y plus y squared into dy, where y is not equal to 0. So let's write it fine. So I will write it like dx upon dy is equal to x into e raised to power x upon y plus y squared whole divided by y into e raised to power x upon y. So let's say x is equal to vy. So dx will be equal to dx upon dy will be equal to first function into derivative of second plus second function into derivative of first, right? So you can write, see, dx upon dy was also equal to this. So equating both of them, you will have v plus y into dv upon dy is equal to v into y into e raised to power vy upon y plus y squared whole divided by y into e raised to power vy upon y. Y will cancel and y will cancel over here. You have v plus y into dv upon dy is equal to vy into e raised to power v plus y square divided by y into e raised to power v, or v plus d y to dv upon dy. I'll take this y, y and y. So this one y will cancel. You will have v into e raised to power v plus y divided by e raised to power v. Hope you got that. So let's take this v on the right hand side. You will have y into dv upon dy is equal to v into e raised to power v plus y upon e raised to power v minus v. So this will be v into e raised to power v plus y minus v into e raised to power v divided by e raised to power v. That's y into dy by dx, or y into, sorry, not dy, this is dv. dv upon dx is equal to, these two will cancel, and you have y upon e raised to power v. So this gives you dv upon dy is equal to 1 upon y into y upon e raised to power v, or this is equal to 1 upon e raised to power v. Hope you understood till here. So that means e raised to power v into dv is equal to dy. Sorry, this was dy all the time. All right, so now let's do the integration on both the sides. You have e raised to power v is equal to y plus c. And what was v? You had taken x is equal to v into y, or v will be equal to x upon y. So this is equal to e raised to power x upon y is equal to y plus c, or y is equal to e raised to power x upon y plus some other constant k. So this is the required solution of the differential equation, this one. Hope you understood that. So the answer to the question is y is equal to e raised to power x upon y plus the constant k. Hope you got that. So with that, let's move to the last question of this paper. That is question number 11. You have to find the distance of the point 344 from the point where the line joining these 2 points intersect this given plane. Okay. So it's known that the equation of the line passing through the given points, let's say x1, y1, z1, and x2, y2, and z2 is given by x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. So here we have, this is x1, where it is, this is x1, y1, z1, x2, y2, and z2. So the line passing through the required equation of line will be given by x minus 3 upon 2 minus 3. Yeah. X minus 3 upon 2 minus 3 is equal to y plus 4 minus 3 plus 4 is equal to z plus 5 divided by 1 plus 5. So let's say this x minus 3 upon minus 1 is equal to y plus 4 upon 1, z plus 5 upon 6. Let's say this is equal to k. So that means x minus 3 is equal to minus k, y plus 4 is equal to k, z plus 5 is equal to 6k. So that gives you x is equal to 3k, 3 minus k, y is equal to k minus 4, and z is equal to 6k minus 5. Now the coordinate of the point of intersection of the line and the plane is okay. Therefore, coordinates of the point of intersection of the given line and the plane will be given by 3 minus k, or you can say minus k plus 3, k minus 4, 6k minus 5. Now, if this lies on the plane, if this point lies on the Plane 2x plus y plus z is equal to 7. This means 2 into minus k plus 3 plus k minus 4, 6k minus 5 is equal to 7, minus 2k plus 6k minus 4, 6k minus 5 is equal to 7, which gives you 7k minus 3 is equal to this, or wait, not 7, this is 5k. So 5k is equal to 10, which gives you k is equal to 2. So now let's substitute the value of k in this. You will get the point of intersection. So point of intersection is minus k plus 3k minus 4, 6k minus 5. This makes it 1 because minus 2 plus 3, this is 1. 2 minus 4, this is minus 2. And 12 minus 5 gives you 7. So 1 minus 2, 7. This is the point of intersection. Now you have to find out, you have to find the distance of the point 3, 4 from that point. So what are the 2 points now for which you want to find out the distance? So the 2 points are 3, 4, 4 and 1 minus 2, 7. Required distance is equal to root of 3 minus 1 square, 4 plus 2 square, 4 minus 7 square, which is equal to 2 square, which is 4, 6 square, 37, and minus 3 square is 9, which gives you root of 49, or 7 units is the answer. Hope you got that. So this is the required distance, 7 units. With that, we have completed all the 11 questions of your set 3, and this completes your this video. With that, students, the very best of luck for your exams. Hope you understood that well, and don't forget to visit our website www.examsnet.com. This site will help you a lot in preparing your CBSE Class 12 mathematics papers as well as entrance exam question papers. A very best of luck. Keep shining, keep rising higher. That's all for this one. Bye.